All right. Just another 30 seconds here, and we're going to get started. Okay. Well, good morning, good afternoon, good evening, depending on where you are in the world. We're lucky enough to have a lot of participants here joining us from all over the globe. On behalf of Joseph, myself, and the entire Osgard team, we would like to say thank you for joining us today for our first of many webinars. This one particular is called Stop Partial Answers. And today we're all witnessing the AI hype. New tools and solutions are being introduced almost daily for IBM systems. Many promise fast answers, automation, or modernization, but a key question remains: which answers can you actually trust? Shall we continue with old school static analyzer and modernizers, or switch to the attractive AI tools? And most importantly, can we trust them with our production systems? In this webinar, we'll focus on that exact challenge. We'll show you how to get complete, consistent, and confident answers to the real questions you have about your IBM systems, from understanding hidden dependencies and business logic to assessing risks and impacts before making changes or migration projects. A quick introduction. My name is Robert Maratti. I am the Vice President of Sales in North America, and I am joined by our product lead, Joseph Schaefer. I have a small presentation that kind of lays the foundation of what Osgard does, and it'll help you understand this in the future of what Joseph's going to be showing you. We did leave some time at the end for you to answer questions, so for us to answer your questions, so please try to hold them till the end. We do throughout the webinar, we are going to pop up a couple polls for you to answer. We do this to better help us decide what to show on the next webinar, so your participation would be greatly appreciated. And be sure to stay till the end. We will check for participation and attendance and attendance time, and we're going to pick 5 lucky winners who will be granted one of our 5 different giveaway packages, in which we will email you directly to let you know that you won. So let's kick this off. So what we say is what we do is clarity for critical code. And what does critical code mean? So what we mean by that is legacy applications, long-running applications, things like RPG and COBOL, complex systems, the spaghetti code type systems, and then big monoliths, right? So big Java systems or one big single application that has everything tied to it. And this actually brings us to our first poll. So you're going to see it pop up here on your screen in a second. And the first question is, what best describes your role with the IBM applications? So I'll go ahead and give you guys like 10 seconds or so. Go ahead and lock in your answers there. All right, pretty good response rate so far. We got multiple people's consultant partners, advisors, CIOs, developers. Okay, great. Awesome. That's fantastic. Thank you for your participation in that one. So let's go ahead and have a closer look with that focus on IBM, right? So a typical, when it comes to your critical code, it's important to know how it works. And as it's been the backbone of your company for many years, it's reliable and it works. This picture illustrates a common trend inside organizations that we see. As you can see, there are a lot of different roles and communications that go on between them all. And typically they all lead to the developer. In this case, it's Joe. Joe has only one question, and essentially what's going on in the system. All the other team members you see here reflects our common use cases. Can we do a modernization project? Should we outsource the maintenance? What happens if Joe leaves? Now, Joe, being that he is the guy taking care of everything, and he's going to need some tools in order to do his job and to cater to the team and their questions. So let's take a look at some of the tools that Joe has available to him. First off, being a static analyzer plus AI. right? They can usually typically understand code structure and can provide a technical impact analysis. You have the modernizers that can change code to RPG to Java or give line by line analysis. There's the Autodoc and code wikis. They can do a quick documentation and are typically always up to date. And then there's AI code assistants, like something like Bob, for example, that can do fast code generations with file level analysis. Now, the problem with some of these tools is they're only going to give partial answers. So, what about the answers to some of these questions, right? So, as far as the static analyzers go, they typically do not understand the hidden dependencies and the items that are not physically visible in the database, which can provide a lot of remaining questions. Modernizers, they usually can change the code. So that can sometimes create an organizational change and put risks there. In some cases, it can change a team's workflow. And they don't usually also see the hidden blockers and they can't filter dead code. Then there's going to be years of tribal knowledge that is not documented. For the auto documentation, people don't typically have time to read all the documentation and the information that it creates. Teams will usually have problems accessing what they actually need and will spend time fishing through tons of documents and information. Typically, a tool like this does not offer an impact analysis. So if the team wants to make a change in the system, could cause a concern. For the AI code assistants, as long as they're adding more code to these systems without knowledge, they are adding more and more complexity to it because they generate more code on a system that they do not deeply understand. And then it's code without knowledge that you cannot validate or trust. Also, they do not usually have a full coverage, so they're not precise. They can offer usually data protection risks. Usually, these tools are cloud-based and they do not provide an on-premise. And for LLM costs, there are a lot of hidden costs in these systems because they can send a lot of dead code and useless code to the LLM, which in return will burn tokens, and people do not notice that. So after a while, they're going to see a lot of money going out the door, really not getting anything in return. So let's pop up a second poll here real quick. And from this point on, there's going to be a couple more polls. You can click as many answers as you'd like in each one of these questions. So for this poll, which tools do you currently use with your IBM I environment? And I'll go ahead and give you another 10, 15 seconds here and click. I'll check out some of the answers here as you guys are clicking away. Very good participation. That's greatly appreciated. Okay. Looks like AI chatbots, LLMs are leading the way. Mostly green screen, IDEs. Okay. Awesome. Okay. Fantastic. Thank you. So, what we always say is don't change your system to understand it. First, deeply understand what you have. And that's where Osgar comes into play. We add intelligence to your application, which makes your existing system visible for the selected users. As AI accelerates change, system level intelligence is no longer optional for critical software. Now, you might be wondering how we do that. We go ahead and add that for this intelligence platform. We add 4 layers to the existing system. One's going to be data sources. Second's going to be knowledge hub. 3 is going to be features. And then lastly, the client. So when it comes to these 4 layers, first, like I said, data source, we do data processing. We filter the dead code. Then we build a knowledge hub. We index data 3 times with knowledge graph, semantic vector index, and we have some features, minimal features, so we can make it simple and easy for the client-facing layer. It can be a graphic user interface. It can be API. And in the up and coming future, it might be MCP to communicate with AI agents. So why this logic and why this architecture matters, like I've said in the past, do not pay for dead code. As stated in traditional systems, there are large amounts of dead code being sent to LLMs, burning tokens, but Osgar understands that and ranks the data, filters the data, so you can optimize everything. Why the Knowledge Hub matters? It is specifically structured for precise, context-aware outcomes without high LLM cost. So everything is deeply tailored to the critical code. Our features are designed to be simple, hands-on, and easy to start. So unlike other products in the market, we do not provide hundreds of features. It's 4 or 5 features, but in combination of these features, it's going to bring a lot of functionality to your daily need. And our client layers is designed to welcome the future, right? For example, next year, if you might want to build a agentic AI tool, you're going to be able to connect Oscar to the system or use our APIs. As far as deploying Oscar, it's very simple. It's essentially plug and play. There is no reason to touch any code. It's easy to set up with minimal features. We simply plug it into your data source and it goes to work building your knowledge hub with precision. And to address security, compliance, and data protection consideration in different industries, we do offer various deployment models supporting on-prem, cloud, and hybrid. And my final poll that I'm going to ask you for, at least for this part of the presentation, well, I'm sorry, I have one more slide to show you. So Oscar is not a code modernizer, a static analyzer, auto documentation tool, or an AI code assistant. We are an enterprise code intelligence platform. So we deeply understand your existing system, including the business logic, and then we become that source of truth connected to all the selected data source. Doesn't matter if it's 30-year-old legacy code or 30-minute-old AI generated code. Now I'm going to put up the last poll that I mentioned before, but once again, you can click as many answers as you want here. So where do today's tools fall short for you in your environment? And once again, take 10, 15 seconds here. I'll go ahead and look at some of the answers. Okay. So of course, the number one answer right now is what we hear the most. Business logic is not deeply understood, followed closely by the hidden dependencies are hard to see. So, okay, fantastic. Okay, great participation there. Thank you for that. So I'm now going to hand the microphone over to Joseph. He's got a couple slides to prep you for his demo of Oscar. So Joseph, I'll go ahead and hand it over to you.
Thank you, Robert. Yeah, so before I start with my demo, I want to review a few concepts that give you a bit of insight what we have done to stop partial answers. It should lay a bit the foundation also that you then later see what I'm showing in my demo. So at Oscar, we introduced what we call power tables. And it is Oscar's way to make long lists and table data more complete, accurate, and grounded in the backend database that we have in the Oscar platform. Why is that important? What we have seen with Oscar is that LLMs are especially have a weakness with long lists or comprehensive table data. If there are, for example, more than 10 or 20 rows, the data become less accurate and the LLM start hallucinate. Therefore, we introduced these power tables that fix that problem. And the way this works is that instead of letting the LLM generate a table output, we actually generate a query that we run in parallel in the backend and we merge the result of the query into the output of the chatbot. And this is what you see here in the output. You see here the dashboard of Oscar AI. And on it, can we go back one more time to the last slide? I just want to make sure we see the chatbot on the right side. You see here the users can ask questions on the right side, and when you get a table, users see always an icon and can view all the rows of the table. And when users click on that, users can actually see the full output of a table, which is generated by a query. Next slide, please. And users can look at the table data separately and copy this to the clipboard or export this to a CSV file or to a JSON file, depending on the user's need. So this merging of table data with the chatbot output and also separate handling of the table data should make it easier to handle also large amounts of data and also ensuring that the table data is actually correct. Next slide. So why does this matter? Before, Robert mentioned that the issue with static analyzers and typical AI LLMs, that there are some shortcomings when it comes to accuracy and amounts of data and hallucination. So this is what the Power Table fixes. It gives you the user experience of an LLM with deep reasoning, but guarantees accurate data. Next slide, please. So, and there is a second improvement that we have built for the OSCAR platform, which is the knowledge graph visualization. Robert mentioned that we index data in multiple ways when we load code information about the application, such as code artifacts or information about metadata about the database. And we stitch all this information together in a knowledge graph. And we have this knowledge graph stored in the backend where the knowledge graph has nodes about programs and subroutines and tables and views. And there are edges between nodes. For example, when the program uses a table, this would be a connection. And so we have that information all stored in a graph. And we use this to support chatbot queries, but it's also very useful information in general for the user. So we expose this knowledge graph directly to the user without any LLM usage. And this is what you see here on this slide. You can you can look, for example, at the source file and see where it's compiled from. You can see whether this is used by a job or whether there are tables that are used. So you can see that information. Anything that we have stored in the backend, you have direct access to as a user. Next, and you can look at one of these nodes and expand the nodes and get more information and drill into information and follow the path of the graph depending on your interest and depending on your problem. Next slide, please. Yeah, so what are the use cases for the knowledge graph visualization? As a user, it helps you discover dependencies instantly. So you look at something and you have maybe an interest, or you see there's a certain problem in your mind, and you can follow right away certain paths in a knowledge graph to get information that is relevant to you. It's also helpful to understand impact and the dependencies between artifacts. Again, depending on your problem, you would follow certain paths in the knowledge graphs to figure that out. It helps to navigate large code bases. So this is then you stop guessing, you just see what is relevant, what is dependent on certain artifacts, and you have accurate information as a user. Especially answering questions like what depends on these artifacts, you can answer in seconds. So ultimately, a knowledge graph is a trustworthy source of truth. There's no hallucination. It's accurate information that's provided from the OSCAR platform. Next slide. Yeah. All right. So next, I will show you a bit about these two improvements that we have built. And I will give you also a general overview of the OSCAR platform for folks that haven't seen OSCAR yet. So I will start sharing my screen in a moment. All right, I hope you're seeing my screen now.
Yep, we can see it.
So this is what you see. Pardon? So this is the screen that this is the dashboard of the Oscar AI platform. This is what end users essentially see when they use Oscar. You see here on the left side a typical documentation outline with information about documentation pages. You see on top a search bar, and you see on the right side the chatbot. And you see in the middle the area where you see the documentation pages or visualizations, which is just a special form of documentation in Oscar terms. Please note this documentation outline. This is very tailored to the application. It's not just a generic outline. When you drill into some of these items, for example, external integrations, it really depends on the application, what items you would see here. So Oscar generates these documentation pages in 2 steps. First, generating an outline that is that fits your application, and then generates the pages accordingly. Typically, when you get started with Oscar, you want to get a bit an overview of the application and understand what the application is actually doing. And this is where the functional areas are very, very helpful. And for Oscar, we use here a honeycomb visualization that gives you a bit an overview of the different functionality areas. What we are currently see here is an ERP application from specific group. The application at specific group, there's part of the core business is managing projects, doing recruiting and talent management, to do time tracking of projects, to do invoice and billing, to just name a few of these areas. Please note these areas are completely reverse engineered from the code and the database catalog. And Oscar is also using information from display files to find good namings for these functionality areas. So there is no user involvement in creating these clusters. Now, looking at these clusters as a user, you can drill into these, look at the details of these clusters. I just click now on one of these clusters, for example, invoice and billing lifecycle management. There's a summary page where you see the functionalities summarized, the most important programs, the most important tables, the most important entities. There's also a documentation tab about this functionality area, where you see the key components, the main database tables, views, batch jobs, and also business processes. So for example, for this functionality area, there's invoice generation. And we see here there's a manual process and an automatic process. So there are two different types of processes. And typically information on documentation pages always heavily linked with actual artifacts that come from the applications. You see here, for example, these are all programs, links to actual source code. So we see here so different types of business processes like invoice generation, like approval process, like payment process, like expense tracking, like dunning. We can click into one of these, and you see for each of these processes, you see the steps and the areas that these processes cover. And when I click on the link, I can jump right away into the source code. For each source code, you see again, there are tabs like documentation where the source code is documented. So for example, for this program, you see a summary of the functionality, the indicators that have been used, the code, an explanation of the code, like how the code logic is executed. the database operations with some examples of some SQL examples, screen interactions, if there are any, and so on. Now, for each application artifact that you see in OSCAR, there's also now a graph tab where you look at what we have stored in the backend in the knowledge graph. And this is now an example where you see the program I just opened. You see here different color-coded items. The green items, for example, are tables. When I hover over these tables, I see the information what these tables actually are, like employee salary records or financial details and so on. I can use also certain filters to filter down to only certain types of artifacts and see, for example, only the tables. And I see here display files, right? And then of any of these artifacts, I can always click and get more details. For example, this is a display file. I can open the display file, see the source code for the display file, can do a preview of the display file, or look at the documentation of this display file, or look at the graph of this display file. There's also some information then where it's referenced or used, so I can jump right into it. So there are multiple ways you can navigate through the application to see all these artifacts. I'm going now back where I just came from. So we looked, for example, at expense tracking. Maybe another interesting process is dunning, where we have, for example, a program that that sends payment reminders. When we look at this source code, we can see a documentation for this source code. Again, a similar pattern here, that you see a summary of this of the program. You see the code explained. You see database operation, sample for SQL statements, indicators explained. So this is typically included in the documentation. And again, at the graph, when we switch to the graph, we see here, for example, certain tables that are used by this program. And there is also this a database view used by this program. And for example, here we see the program uses a table dunning process information. And what I can do is I can say, well, I want to see anything that relates to this node, and say expand. And as you can see here, now we see more information about this table, and we see, oh, other programs are actually also using this table. And I can go now to any of these nodes and expand them and follow the paths and get the children of this node. So depending on what I'm after and what I'm interested in. Now, all these knowledge graph and documentation pages in general, you can always select something. And I can also add this to the chatbot and ask questions in the chatbot directly about a certain node. So for example, this table, I could just ask, what is this table doing and how is it used by programs, just as an example. So what we have done on the OSCAR platform is that you can look at pages or visualizations and easily ask questions to what you see there. And also the chatbot outputs typically generate links back to the documentation pages, so that there is a nice integration between the chatbot interface and the pages and the visualizations. So you see here, for example, I can see here a good explanation what this table is about. With how is it used in programs. I see here there are three 3 programs. There's no surprise here. We see here the 3 programs also in the knowledge graph. I can easily always just click on a link again. I see the source code, can get documentation, see the graph, and so on. So I hope you get an idea. How you switch back and forth between documentation pages, sources, the graph, and the chatbot output. So this is seamlessly integrated. Another interesting thing is a good chatbot question could be, this is about the Dunning process. We could ask in general, show a diagram of the Dunning process in general. So this is something when you want to see more diagrams than the documentation pages give you, you can ask directly in the chatbot also to generate new diagrams of areas of your interest. Diagrams usually take a bit longer. Yeah, while this is generating, I will switch briefly to the data model to also give you an idea on how the data model can be used to get more information. So the data model view is something that is also very useful for users to dive into details of tables and see relationships between the tables. And so, for example, you can see see information about the tables. As you can see here, there are many tables, hundreds and maybe thousands of tables. And very often it makes sense that you filter down the data model to something that is relevant to you. And in OSCAR, the way you do it is that you describe the topic or the area of interest. And for example, if I'm interested in Dunning, I just enter Dunning, or show me all tables about Dunning, or whatever way you want to phrase it. You can just add this the filter in natural language, and OSCAR will filter down the information to whatever you're interested in. And we see here there is a Dunning table. And now what is here interesting is very often I want to get a bit more context to this table, and I see the relationships to the table, and I can add multiple levels of relationships, so I can expand the context for tables that are related to the table that I have been looking for, right? So this helps greatly with the analysis and understanding of a table, and the related tables are equally important because very often you're looking at not just the tables are dependent on each other, and you see here the Dunning table uses the outgoing invoice master table, and this table then depends on again on other tables. So to understand, to get a whole picture of what is relevant, it's important to take also the relationships into consideration. Now, when you look at a certain table, you can also click on it, see the fields, the indices, the usages in the programs, views if there are any existing ones. There's also a documentation page on this table where you see the the table fields, again, the documentation on the table. I will get a bit of diagram of the relationships to other tables and a graph, if you're interested in. Yeah, so this is the data model. The next section here for on the outline that users can use, or that for information that users can look at are the sources. Here you see all the sources that are loaded into OSCA in folders, and you can directly either search for it, or you can jump directly to some of the sources. And I just try. Here's one. I go to a folder to see to open up one file here. Let's say we want to go to expenses. See here source file. See the documentation to the source file. See here, for example, yeah, the database operations, SQL statements, indicators, if there are any indicators used, and or look also at the graph where you see dependencies, and what we see here, for example, there are also multiple views used within the program, and as mentioned before, so I can hover over and get more information about this view. I can expand any of these nodes or ask chatbot questions. So it depending on what I'm after as a user. Next, I want to show a bit the component catalog of OSCA. So in OSCA, we are continuously expanding our catalog on application artifacts, where you have a complete list on documentation pages, for example, on scheduled jobs. So here is a complete list of the application of jobs that are, and you see here when they are scheduled. You see also the name of the job, and you can click on the link, and then you see information about the job with some summary information, with a documentation of a job. So, for example, this is a bonus payments reminder job, and you see here the steps that the job executes in the visual diagram, and you can again look at the graph where you see information on what this job is doing. You see here job is connected with a program. I can expand the node and see more details what this program is doing. And what I'm actually seeing here, this program actually is compiled from a certain source, and it's actually calling another program. I can also expand this node, and with this, by expanding this node, I see that this other program is using two tables. And so this is a way I can explore an application landscape, and I can explore what are the dependencies between the artifacts. Now, besides scheduled jobs, we have also service programs. Similar idea. You have a complete list of the service programs, complete list also of the tables. For the tables, we also show the program usage and the count, how often is used by programs, and the top 5 programs that are used, that are using a certain table. So you get here also in the list. This is sometimes useful information. Here we have also then a dedicated page for database views, where you get a full list of all the database use of the application, and with program usage counts and the top 5 programs using the views. Then in addition, OSCA identifies all external integrations. Here, for example, the the application has a gyro integration and a Payhawk integration and email server integration and so on. All these pages are very tailored to the type of integration that you have. It describes on how the integration has been done and what the endpoints are. There are usually also diagrams that show how the integration has been done, and provides so OSCAR provides you information that helps the engineer understand how the integration works. External integration. Then there is a section about code insights. Code insights is just information about the code itself. This is about the code structure, about variables and global constants, for example, or error handling. Error handling is maybe an interesting one because there's very often a centralized way to do the error handling, and utilities that are typically used, as you can see here. There's certain error sources that are, or utility functions that are used, and in general, a description how error handling and error logging is done in general. Another interesting page often is coding style and standards that, for example, naming conventions, how are key fields named or how are constants named. You see here there's key underscore, a K underscore, a C underscore for constants. So how are procedures and subroutines named and so on. So all these things are reverse engineered and surfaced by OSCAR automatically. Now, we have a dedicated section also for data management, which focuses mostly on the database itself. There are different documentation pages for certain clusters of data, like how is this an ERP application, how is corporate structure management or corporate data in general organized, and what are the main entities like firm, company, department, and so on. And documentation pages, this documentation page summarizes well on how this type of data is organized. Typically, there's also an entity relationship diagram that shows the relationship between the data and describes how the data is organized and how the data is used. You see this for different clusters of data or data groups. So there are different documentation pages that users can use. In addition, there is a documentation page about index management, or also for databases, there are standards and conventions on, for example, how you name your tables and columns. Just to give, so column naming is often interesting, or how indexes and constraints are named, or how foreign keys are defined, or how database views are named, and so on. So all this information is automatically surfaced from OSCAR. Next is we have also an onboarding section. This is for new people that are joining the team and that are interested in learning about the application. This is more as an onboarding section. There are documentation pages, how you do your first code change or how to do database changes. So this is meant for the onboarding itself. Last but not least, I want to mention there is an own section for inactive objects. This is where I get an overview of inactive objects. Inactive objects are objects that are essentially dead objects that OSCAR considers not as active and dead. And these can be dead programs, can be dead sources, can be dead tables or views. And this is part of typically of the installation where OSCAR figures out what code is actually used and what is actually never used or has never been used. And you see here, for example, from 2051 programs, there are only 725 used, and for sources, there's also a significant part of the sources that is dead and has never been used. This is a critical step that we do initially. This saves us a lot of costs also in LLM processing. And also it reduces the noise and delivers ultimately more accurate chatbot answers and more accurate documentation pages if we eliminate any kind of dead code and noise, and it makes sense to do this upfront to have a better quality for chatbot answers and documentation pages. So this is um, a good overview what the documentation includes and what the OSCAR platform in general provides. I want to show one more example. I'm just getting back to this. I want to try this question one more time. There's sometimes a network glitch, and it may happen that the diagram doesn't show up right away. I do hope that this works this time. Yeah. Yeah, so when you want to request a diagram, you see here, for example, the dunning process. This is when you check invoices when they're overdue, and there are dunning levels that are, all this information comes from the code and has been extracted from the code and the data model. And this diagram is now a summary of how the actual process works overall. So it means there's, for example, a lock, and depending on what the lock is, there is a reminders sent, and there is a date calculated for the reminder. So typical process that happens when you send payment reminders, and so typically you have different levels. Then where you do send multiple reminders till you finally, the process then completes. All right. One thing that I want to show is, because we talked about partial answers. I want to show an example where LLM pretty much have really trouble answering questions, and where the power tables really help to get accurate answers. So, for example, when you have a question like list all tables sorted by usage in sources. So this is essentially, you touch all tables, or you want to get the full list of all the tables in the application, and we want to sort them by usage and based on how often these tables are used in the source. In the past, we noticed when you ask such question to an LLM, it miserably fails. But now with power tables, actually we get a correct answer. The reason why is because we generate a query to answer the question, and the query goes back to our backend database and to our knowledge graph to get that information. And we see here now there are 228 rows, and I can look at these tables and see the actual usage count, and I can jump right away to these tables to get the information about these tables. So, for example, we see here the SPG team member information is used heavily, and there are 130 sources that use that table. There is to just get an example, we can just take, for example, this table and say show usages in sources of table. What we just have, we saw it before, this was 55. Ask the question in the chatbot, And we see here there are 55 rows, and so this is very consistent what we have seen in the other table. So we get here accurate answers. So I just wanted to demonstrate this works also for large amounts of data, not just for a couple of rows. It works with hundreds. It works also with thousands of rows. The reason why this works is because this is not done by the LLM. The table data itself is not done by the LLM. It's done under the hood by executing the query that you run against our backend database. All right, this is all I wanted to show today. This completes my demo, and I want to give back to Robert.
Yeah, thank you, Joseph. So I will just share my screen. Two quick points we're going to make here before we jump into answering a few questions. So so obviously the future is already running, right? So at a time when AI is reshaping enterprise structures, we're proud to help organizations engage with AI safely, reducing exhausting manual work and risk without disrupting the system, teams, or workflows they already rely on. So let's go to our last poll before we jump into the questions. So this one, once again, you can pick as many answers as you'd like, but what would you like to do next? Or, what would you like to see from us? So if you're interested in being one of the winners that I spoke about at the beginning, make sure you click number 3, because we will be reaching out to 5 lucky people to let them know what they have won. So I'll give everyone another few seconds to answer that one. 5 more. All right. Awesome. Awesome. So while you guys can continue to play around with that, we will jump in and answer a couple questions. We have roughly, how many more minutes do we have here? We have about 6-7 more minutes. So let me jump into the questions here, Joseph. Let's see what we got. First question, Joseph. How frequently can we refresh Oscar application?
Yeah, Oscar has a data refresh functionality, and as a customer, you can define how frequently you want to do the data refresh. Typically, customers do the data refresh daily or weekly, so this is a good frequency to keep the data up to date that is found in the chatbot and in the documentation.
And then when some table and program gets migrated, can they get the updated information from Oscar?
Yeah. So this would be a data refresh. Data refresh can be also triggered by the user or manually anytime, and it can be scheduled, as I mentioned before, on a daily basis or on a weekly basis, depending on your needs.
And then does Oscar integrate with any architecture tools?
I think the question here is whether we support certain types of frameworks and
Yes.
that generate their own artifacts. The way Oscar works is Oscar always reads their artifacts and then parses these artifacts and to understand them and to understand dependencies and so on. So if there is a new tool that Oscar has never seen, the sources are available, but there are the full understanding is limited of artifacts from frameworks that Oscar doesn't natively support. So we do support artifacts, any kind of artifacts, but of course the artifacts that Oscar fully understand, you get the most out of it, and we can create a richer user experience. So please talk to us so we can let you know on how well this framework is supported, whether we have experience already with it, so we can, and also we are interested in actually expanding our portfolio on such frameworks.
Yes, and we have another person asking here, can this run on-prem, assuming the sufficient hardware resources are available?
Yes, so especially for in the IBM world, the standard installation of Oscar is on-premise installation, and so the Oscar makes sense that Oscar is close to where the source system runs, and then you have less challenges with networking and firewalls and getting access to the source system. So it's a very I would consider from a security perspective actually a best practice to install Oscar close to where the source system is and install it on premise.
And as it is an enterprise code intelligence solution, what platforms are supported right now? And then if there's anything on the roadmap that you can share.
Yeah, we support IBM I, and we support, and this is RPG and COBOL, and we support soon also mainframes, IBM mainframe, and this will be, we want to introduce and launch it by end of February. And by end of April is our goal to have Java support. So there's this will be a new object-oriented language, and we will support anything that you know from the Java platform, like packages, classes, and there will be new visualizations. And our goal is to launch the Java platform by end of April.
Awesome. And then the last question here, because people want to be conscious of everyone's time. I believe this question is supposed to read, can I use Oscar with GitHub or any code repository platform?
Git is supported. However, it depends what platform or what kind of code you use. When you use, let's say, in your code PHP or some language that we don't support yet, I think the information you get from Oscar is rather limited. But any platform that we do support, you get this rich user experience that I've shown you in the demo.
Perfect. Perfect. Well, there's definitely some more questions here and some more comments, and we will respond to all of you. But that does it for our time today. I definitely want to be respectful of everyone's time. Like I said, on behalf of myself, Joseph, and the entire Oscar team, thank you today for joining. This was a great turnout for being our first one. We're very much looking forward to doing the next one. We'll probably be doing a couple more before we go to the Common Conference in April, which we'll be at. And if anyone here is working with the mainframe, we will be at the Share Conference at the end of February in Orlando. So we plan on doing a couple more webinars before then. Again, thank you for joining us today. We look forward to communicating with all of you. This recording will be available. You will have access to it. And like I said, we will be picking 5 lucky winners, and you'll be hearing from us within the next few days on who won the prizes. So thank you, everyone. We hope you have a great rest of the week. We hope you all have a great 2026, and hopefully we'll see you real soon and being an Oscar customer. Have a great day. Thank you.
Thank you.